Hi, everybody. This is Math 1332, Test 2 Review. If you go to the homework section and scroll down after the last homework assignment in this area, you'll see Test 2 Review. That's where I'm getting the problems from, okay? So that's where I'm getting all these problems from. So I am just going to go do them. Now, I'm not doing all of them. I think there's like 50 of them. I'm only doing these. These, you can find out, are located in the announcement section. In the announcement section, I say test 2 review, do only these problems. What I did was I went to the test, I went to the review, and I found problems that match or are similar, or very similar. So concentrate on the problems I'm about to do, and not all of them. You can do them all if you have the time, but let's concentrate on the ones I'm about to do. So the first one says, let's do number 3. Okay, so number 3 says, identify the pattern. Hang on, I'm trying to get my pen to work. Okay, there we go. So identify the pattern. And by the way, your number 3 might look a little different because they have multiple number 3s. So if you look at this, I try to identify the pattern. Well, 2 to 8, 8 to 10, 10 to 18, 8. Oh, I think I see it. Look at this pattern. If I add these two up, I get this one. Next, if I add these two up, I get this one. So if you add the previous two up, 10 and 18 is 28. 18 and 28 is 46. So to get the next number, you have to add these two up. 28 and 46 is 74. That's number 3. So you'll have a problem similar to that. You just have to identify the pattern. Okay, I'm now going to number 7. Be a little patient with me because I'm navigating using this thing here. Okay, here's number 7. Traveling at a rate between 40 and 70 miles per hour for 6 to 9. Select the best estimate. So by the way, this is 40 to 70 miles per hour. So at an average rate between these two, what you need to do is just find the average of these two. Add them up. 40 plus 70 is 110, and then divide by 2, which is 55. And we're talking about miles per hour. And then here, for 6 to 9 miles, so you need to find the average of this. 6 plus 9 is 15, divided by 2 equals 7.5. So if you're driving 55 miles an hour for 7.5 miles, you have to multiply those two together. 55 times 7.5, and I get 412. And the closest one to 412 looks like this one right here. I mean, this is kind of close too, but 405 is closer, so that's my answer. By the way, you can't see all the answers because when I printed out, it didn't show all the answers, but that's the answer I'm choosing. That's number 7. We're now going to 10A. Is there another way I can scroll down? I don't see it. I have to grab the hand and then push it down. All right, so we're going to do 10A here. By the way, there are 22 questions on the test, and I think I'm going to cover about 20 of them on this review. I think I'm going to do about 20 of them. So we're just doing A. Estimate the yearly increase in the average atmospheric concentration. Express your answer in parts per million. So I want the yearly increase. In other words, the yearly increase is the same thing as saying, what's the slope? So in order to find the slope, I need 2 points. I'm using the first bar and the last bar. We want to know the slope of this. Did you see? We want to find the slope of this line. And I'm going to write coordinates. The first bar, the x coordinate is the year 1950. The second coordinate is how high it goes, 307. The second bar that we're doing, this one here, the year, this is the first one, and this is the second one. Sorry, this pen's a little messy. I'm using a new right pad and pen. So the first bar of the year is 2015, and it goes up to 394. All right, don't forget about the slope formula when you have 2 points, y2 minus y1 divided by x2 minus x1. So I'm just going to plug that in. Y, this is x of the first point. This is y of the first point. This is x of the second point. This is y of the second point. And the formula is y2, which is right here, 394, minus y1, which is 307, x2, which is 2015, minus x1, which is 1950. All right, so we'll do the top. 394 minus 307 equals 87. And the bottom, 215 minus 1950, is 65. So we have 87 divided by 65. And it says approximate to the nearest tenth. Tenth is 1 decimal place. 1.33. If you look at 1 decimal place, you look at always to the second decimal place to see if you're going to go up or down. Since it's 4 or less, that first decimal place stays the same, and there's my answer. 1.3 parts per million. It increases every year. That was a yearly increase. 10A. 13. I'm going to problem 13. Express the set using the roster method. Well, if you look at this says X is an element of the natural numbers. X is an element of natural numbers are counting numbers. It's like a baby learning how to count. They don't say 0, they say 1, 2, 3. So natural numbers start with 1, 2, 3, 4, and they go all the way to infinity. But they're whole numbers, and they start with 1. So let's look at these numbers. The numbers, X is between 5 and 11. And this says it equals 5. So 5, 6, 7, 8, 9, 10, and 11. Hold on. There's no equal sign for 11, so 11 is not part of the answer. Do you see that? So it's just 5, 6, 7, 8, 9, and 10. And means which numbers are in common. Well, if the natural numbers go from 1 to infinity, all the whole numbers, and we have 5, 6, 7, 8, 9, and means what's in common with these two sets? Well, just the 5, 6, 7, 8, 9, and 10 are the numbers in common. And there's my answer. Don't forget, this test is 22 questions. It's all multiple choice. You may use your notes and a calculator. No cell phones. That was 13. I'm going to question 16. First, I got to find it. Find the cardinal number of the given set. Another way of writing the cardinal number of set A there is write it like this. You see this little n. The cardinal number of set A. Cardinal number is the number of items. The number of items in the set. And they have to be distinct items. So that means if you have a repeating number, you can't count it twice. 6, 11, 16, 21, none of them count twice. There are 1, 2, 3, 4, 5, 6 items in the set. So the cardinal number is 6. And just to show you, 1, 2, 3, 3, 4, the cardinal number of this set is 1, 2, 3, 4. You don't count 3 twice. So the cardinal number is 4. You don't distinct items. Each item has to be different to be counted. That was number 16. I'm going to number 21. Here's 21. So we have to know this is a subset. Subset is part or all of the existing set. We want to know if these are subsets or if it's not a subset. If they're subsets, then every letter is in each of the other one. The, 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 country, COU, COU, NTRY, T's already there, RY, SIDE, SID, and E. So yes, they're subsets of each other because every letter from the left one is in the right. The right one is the one that you should say is the big one. Just as long as every number in the left side is in the right side, we're okay. Not the other way around, right side to left, but every number in the left side has to be in the number from the right side. All the elements, yeah, there we go, left side or right side. All the elements in the first set are in the second set. You can't say every element in the second set is in the first. It has to be the first set is in the second set, if that makes sense. I'm going to 23. Once again, these are very similar to what's on the test. Determine whether it's a subset or a proper subset. The only difference between a subset and a proper subset is proper subset, the two sides can't be the exact same. They can't have the same elements. A subsets have pieces of the other set or all of it, but a proper subset only have pieces. You can't have everything in one subset, in one set as the other to be proper. So if we look at natural numbers once again, natural numbers are 1, 2, 3, 4, 5, goes to infinity. X is between 4 and 8, but there's no equal sign. So it's just 5, 6, and 7. Do you see we can't include 8 because there's no equal sign. We can't include 4. There's no equal sign. And is an intersection of these two. The intersection is 5, 6, 7. Well, we're not even worried about that. We're just seeing if these two sets are proper subsets or subsets. It is a subset because for a sub is this one. Oh, wait a minute. I think, give me a second. This is 1, 2, 3, 4, 5. And this is just 5, 6, 7. So the set 1, is it part or all of set 2? No, there's a 1 in set 1 and there's not a 1 over here. So none of the above. The first set has to be part or all of the second set, and it's not. Determine whether the set of natural numbers between 5, 6, 7 is a subset of the natural numbers, but 1, 2, 3, 4, 5, 6 is not a subset. Determine whether that or that, both or neither, can be placed in the blank to make it a true statement. That's a tough one. I would pick neither on this because, but we're not putting it between these two. So give me a second. I'm going to go it. I am back. That was quick. I read this problem wrong. So let's look at so I apologize. I read this problem wrong. So set of natural numbers are 1, 2, 3, 4, 5, goes to infinity. These numbers are 5, 6, 7, not 8, just 5, 6, 7. And the intersection of these, the and of these two, are just 5, 6, and 7. Do you see? Just 5, 6, and 7 are common. But then we have the other side. I was wondering, did I not read the other side? A set of all natural numbers between 4 and 8. Natural numbers between 4 and 8 are 5, 6, 7. 4 is not between 4 and 8. It doesn't say inclusive. It would say inclusive if 4 and 8 were part of the answer. So the numbers between 4 and 8 are 5, 6, and 7. If you notice, 5, 6, and 7 they're the same sets. So we have to choose between this one and this one. A proper subset, this is a proper subset, cannot equal. Do you see there's no equal sign? So these two are not proper because they're equal. So we just say they're subsets. Do you see the subset has the equal sign on the bottom of it? So if they're equal, we call them a subset. If they're not equal, it's still a subset, but we can also call it a proper subset. So this is the correct answer for this problem. That's 23. I'm going to problem 30 now. There we go. Problem 30 says find A union universal. Well, here's A. Here's a universal set. A union, a U, which is a union, means a marriage. That means you bring everything. You can call this the man. You can call this the woman, if that's who's getting married. And you bring everything into one set. Look, I have a refrigerator and she has a refrigerator, but you only bring one refrigerator to your new apartment when you get married, right? You don't bring two refrigerators. So when you do a union, you're getting married, but you don't bring two of the same of anything. There's a two, there's a three that's going into the new apartment, there's a four, there's a five. She's bringing a six. I have a six. We both have a microwave. We're only going to bring one microwave into the apartment. The other one's going to get sold at a garage sale. We both have a big lazy boy chair. We only have room for one. And we both have a bed. Who knows whose bed we're bringing? I don't want to sleep on her bed. Who else has been on that? Anyway, so that's the union. So the answer to this is 1, 2, 3, 4, 5, 6, 7, 8. The marriage of the two. And sure enough, I did problem 29, which I wasn't supposed to do. I was supposed to do problem 30, but it's the same thing. Actually, no, I'm going to do problem 30 right now because it's different. So let's look at problem 30. Here we're taking the intersection. Do you see it's not a U, it's an N, and that's an intersection. And we want to know what's in common with these two. We both have a 4. 4 is in common. We both have 8s. 8 is in common. We both have 9s and 10s. These are the only numbers in common. The N means what's in common with these two, and the answer is 4, 8, 9, and 10. I'm going to problem 31. Here we want to do A intersect C. What's in common with A and C? So we don't care about all the other distractions, all these other letters. We're only looking at A and C. The B's are in common. D's are in common. E's are in common. H's no. I's no. That's it. B, D, and E. G, J, K. There's no G, J, K. We're only looking at A and C. Those are the ones in common. Problem 36. The Venn diagram to represent the set A union B in the roster. So not. This means not. So first I want to do A union B, okay? I want to find a marriage. Remember, union means a marriage. It's a marriage of everything in A and B. If you look in A and B, these are all the things in A and B. You know, those are all the numbers in A and B. 3, 6, 7, 12, 15, 17, and 20. But the problem asks A union B, but what's not in them? Well, the only things not in a marriage of A and B are 24 and 26. So first you got to figure out what's in A and B And then this says, oh, I only want things that are not in A and B. So the answer is 24 and 26. Those are not in the circles of A and B. That doesn't sound too bad. Study real hard for this test. Number 37. A intersect not B. So first I want to find everything in A. A has 2, 6. Why don't I write it out in roster method form? A has 2, 6, 8, and 10. You see, these are in A. Now we're going to find things that are not in B. Not in B. Well, these are in B. These are in B. So I need to write down everything that's not in B. 2 is not in B. 6 is not in B. 23 is not in B. And 27 is not in B. So I wrote not B, I wrote A, and we want to do intersection. What's in common with these two? The numbers in common are just 2 and 6. So my answer is just 2 and 6. What's in common with A and things that are not in B? So first you write down everything in A, you write everything that's not in B, and then you find what's in common with those two. Question 42 is next. I think these are fun. Hopefully you find them fun also. I hope so. Use the Venn diagram on your list to find what's in common with B and C. That's it. Look, here's B. This is circle B. This is circle C. What's in common with B and C? Do you see? These are all the numbers in C. If you look at circle C, these are all the numbers in C. I'm going to change my color to red and circle all the numbers that are in B. Those are all in B. What's in common with B and C? Well, 12 and 14 are. They're the only two that are circled, the only two numbers circled twice. 12 and 14. You see how that's what's in common with B and C. Oh, I skipped one. We need to do number 39. It's on the previous page. There we go. Ooh, am I floating around on your screen? This is scary. Trying to entertain myself. I'm all by myself. Oh, Charles! I didn't even see you here. I apologize. What, can you hear me, Charles? I'm hoping you can. I don't even see where I can talk to you. There we go. Public chat. I didn't even see you show up. Can you hear me? Are you even there? Or are you just pretending to be there? All right, you have a good. Just hang in. I'm going to finish the chat. It's going to be recorded. Good morning. I'm going to continue on. I didn't realize somebody was here. I'm glad you popped in. All right, so I'm going to do number 39 next. 39 wants us to find A union B intersect C. So I'm going to find this first. I always look for the parentheses first. So just B and C and what's in common. Intersection means what's in common. So what's in common with B and C? The ones are in common, the threes are in common, and the fives. So 1, 3, and 5 are in common with B and C. Then we're going to take a union of this with A. A has 1, 2, 3, 4 in it. So we're going to do a union of these two, a marriage of these two. So every number has to count. We both have a 1. So a 1 goes in here. We don't both have a 2, but this one has a 2. So it still gets counted. There's a difference between intersection and union. Union means everything goes into the new apartment. 3, 4, and also we have a 5 over here and 5. So this is the union of A and the intersection of B and C. First, I found the intersection of B and C. Then I wrote down what A was from over here. And then I'm doing a marriage. I'm putting everything into the new apartment. Once again, if we have double, we don't write it double. We only write it one time. And that's 39. We've got 6 problems to go. I'm going to problem 43. There's 43. Okay, I think this might be the hardest one of them all for the. I think this might be the hardest one of them all for the test. Something like this. Even in my face-to-face class, we had a really hard time. They give you this picture and they say, "Okay, write down what you think it is." Well, there could be a lot of different things. So when you approach this problem, um, sometimes it's best to do a process of elimination and just show you. The shaded region is what you're looking at. A intersect B. This is what's in common with A and B. Do you see? Only this section is what's in common, but there's a lot more shaded in. So I know this is not the answer. Do you see? And so we're going to just try to go through a process of elimination. So I know C is not the answer. Let me erase that mess. And we know C is not the answer. A union B is everything in A and B, a marriage of A and B. However, it's not. So everything that I did not shade in, and I'm going to do it in red, everything I did not shade in is all of this. However, we have to count the stuff inside B, but we can't because it says not A union B. So that can't be the answer. I'm going to erase all this again. So A and C are not the answer. It's really easy to find out which ones are not the answer. Let's look at B. I'm going to shade everything in B. I mean D. So first I'm going to do shade everything in B. And everything that's not in A. Do you see? This is not in A. And all of this is not in A. So that looked like it worked. The last one, D, worked. I wanted to save the confusing one, the complicated one, for the end. Luckily, we found the answer. The answer is D. So you got to figure out which one of these is the true shaded in region. and that's 43. I'm going to problem 44. Same thing. Oh no. I don't want to do this one. A union. Let's. I'm looking for which one seems the simplest. This right here is B. This part right here is B intersect A. So I'm thinking this might be it. I'm thinking that might be it. So I mean that's what I'm looking for. So first we're going to shade in red everything that's in B. So this is all of B. That's all of B. Now we're going to do in blue, I'm purple, I'm going to do everything that's in A union C. Everything that's in A and everything that's in C. And we're going to do the intersection. Where do we have two colors at? And I'm going to do the two colors in black. Do you see right here? We have two colors. We have blue and red. And right here we have two colors. We have blue and red. And that looks like the answer. Do you see all that I just shaded? I'm going to erase it now. Do you see that's what I shaded in? So the one I picked first is the correct answer. Once again, you just go through the process of elimination. I realized that B and union A, union C, it looked like the answer. Everything in A union C, which is all of this, and intersecting. What does this intersect with B? Well, that all intersects with B, so that's the answer. That was 44. Hey, we have a telephone number that arrived. Welcome. Telephone number. This is a recording, and you will be able to see it later on also, everything that you've missed. I'm on 47. I have 4 problems left. I'm on problem 47. Can you hear me? Telephone? Charles, you're not getting any audio anymore? Oh, telephone left. Charles? Testing 1, 2, 3. You'll get the audio on the recording. I apologize. Hopefully it'll be on the recording. Are you getting any audio now? Can you hear me now? Testing 1, 2, 3. All right, 47. Chart below shows the most popular vacation destinations. And it says, let me get my pen. It says Tahiti should be placed in what region? Which are these regions? Let's look at Tahiti. Where is it over here? There's Tahiti. It's in 2005 and it's in 2004. So Tahiti's in 2004 and 2005. Here's the circle for 2004. Here's the circle for 2005. This region is in all 3 sections. Do you see this region here is in 2004, 2005, and 2003. Tahiti's only in two sections, 2004 and 2005. So this has to be Tahiti. It's in 2004 and 2005. So what region is Tahiti in? Roman numeral 6. So Tahiti's in Roman numeral 6, that region. That's 47. I'm going to 48. Okay, so this is a really crazy one, I think. When I first looked at it, I was saying, what? Um, these C. Hang on, I'm trying to find my pen again. It's hard to get this pen on this board. Circle C is for people less than 20. Circle A is for the people who agree. And circle B is for African Americans. It says the number of respondents that disagree with the statement. Well, all these people here agree with the statement. Do you see? Everything I circled are in the agree section. So even though it doesn't tell you on here, the people in blue disagree because the red circles agree. So 10, 5, and 1 disagree. So there are 16 people who wait, there's more than 16. This person obviously does not agree also because they're not in the agree circle. There are 19 people. It won't let me write it. There we go. There are 19 people who disagree. This person, this person, this person, 16, and 3 more is 19. All those people disagree because the red circles are the only ones who agree. You only agree if you're in the agree circle. Everybody who's not in the agree circle has to disagree. All righty. We are going to 53. Problem 53. Oh no, the Euler diagrams. I should have did a video on Euler diagrams. I really recommend if you have this section in the homework, if you did not read this in the book, I would recommend reading this in the book. If I have time Friday, I'll try to. I don't think I'll have time do a section on Euler, but Euler is really confusing. So read this section in the book. It talks about how to write these circles and everything. Just really quick. This is from the book. What I have here, I'm gonna just show you what the book talks about really quick. They tell you Euler invented this crap. All A R B. The way to write all A R B, all A are inside B. This is how Euler writes it. All A are inside B. All A are B. Then you can write no A are inside B. No A are inside B. So you'd have A here and B here. They're not inside each other. Then Euler came up with some of A's are in B. And he wrote it like this. Here's A. Wait, hang on. It's got to let me write it. There we go. Here's B. Do you see some of A are inside B? And he pointed to this little section. And then he said some of A are not in B. So here's A, here's B, and these are the people, some of A's, who are not inside B. These are some of A's who are in B. These are some of A's who are not in B. So read that section in the book, and that's what the Euler did. All of this just off of these four circles. So we're only going to use these four type of circles. All right. So first, all fish are cold. In other words, all fish are inside cold. They're cold-blooded creatures, right? All fish are cold-blooded creatures. So the fish circle is in the cold-blooded circle. Therefore, a trout is a fish. Oh, we forgot to do a trout. Trout is one of the cold-blooded creatures. So a trout is one of the cold-blooded creatures. Well, we know a trout is a fish, but they didn't tell us that. A trout is a cold-blooded creature. Let me rewrite this once again. All fish are cold-blooded. A trout, let me write a trout. A trout, wouldn't you agree? A trout is cold-blooded. A trout is inside the cold-blooded region. However, I could also write a trout is cold-blooded. That's still saying a trout is cold-blooded. A trout is inside the cold-blooded circle. So you could have wrote it here or here because they're cold-blooded. Therefore, a trout is one of the fish. Well, this trout is a fish. However, this trout is not a fish because it's not inside the fish circle. So this is invalid. This statement is invalid. If you can write it where it's invalid, then the whole thing is invalid. Only you can write it where it's valid. I could have wrote it like this and said it's valid, but if you can write it one time where it's not valid, then the whole thing is invalid. So I'm not writing it like this. I'm writing it like this. And both my statements are true. All fish are cold-blooded. A trout is in the cold-blooded circle also. Therefore, a trout is a fish. But a trout is not a fish. It's not in the fish circle. So we have to say this is invalid. That's why I don't like Eulers. Even though we know a trout is a fish, we have to do the logic version of this. And we have one more. Let's do number 54. This is our last problem. Oh no. Let's see. All factors of 6. All factors of 6 are factors of 42. All factors of 6. First of all, I'm going to put factors of 42 up here. Factors of 6 are 2 and 3. By the way, those are factors of 6. Things that divide into 6 evenly. Things that divide into 6 are 2, 3, 21 times 2 is 42. 42 divided by 3 is 14. 14 is a factor of 42. 6 times 7 is 42. So 6 is a factor of 42. And 7 is a factor of 42. Those are all the factors of 42. 2, 3, 6, 7, 14, and 21. 2 and 3 is a factor of 6. It says all factors of 6 are factors of 42. Yes, 2 and 3 is inside 42. Therefore, some factors of 42, it says therefore, some factors of 42 are factors of 7. Some factor. Oh wait, did I write something down wrong? I don't. It seems like okay. I wrote all factors of 6 are 42. Okay, so I wrote that already. Um, okay, we wrote that. That's the one. I didn't read the second one. Okay, so this is not going to make sense, but we have to write it down. Some factors of 6 are factors of 7. So if we wrote this, the sum has to look like this. These are factors of 6 and these are factors of 7. Do you see? These are some factors of 6 that are in 7. Some where you have to have an overlap. So if, and 7 is a factor of 42. Let me put 7 down here. I'm changing 7 to right here. So see, here's 7. Some factors of 6 are factors of 7. And by the way, also 1 is a factor of 7 and 1 is a factor of 6. I didn't think about that. 1 times 6. So therefore, some factors of 42, these are all the factors of 42 are factors of 7, and some of them are right there. This is a factor of 42, this is a factor of 7. So this is valid. That's a really tough one. You had to write the factors of 6 and factors of 7 like this. That's why I put this second circle that where some of them were there. And 1 is a factor of 6 and 1 is a factor of 7. So some of the factors of 42 are factors of 7, and that's true. In reality, it's all, I would have said all factors. Oh, some factors of 42 are factors of 7. Yes, these are the factors of 42 that are also factors of 7. So yes, I said that one was valid. I hope this video helps. The Euler diagrams are really a pain in the butt, I think. You got to read that chapter to truly understand it. If you try to do the homework without reading that chapter, I really recommend going back and reading that chapter. Let me know if this video helped. You guys study real hard. Test is coming up next week. We